Hi kids. Okay, we are doing lesson 11 today, module 2, and our objective is to multiply decimal fractions by multi-digit whole numbers through conversion to a whole number problem and reasoning about the placement of the decimal. Again, wow, that's a lot of big words to try to do something really simple. And so what we're going to do is continue what we did yesterday. So we're going to take that decimal, and instead of having just tenths like we did in lesson 10, you have hundredths. And so we have two place value positions to the right of the decimal. So same strategy, same exact strategy, the new way and the old way. You can remove the decimal, change it to unit form, just get the decimal out of there, okay? Solve it without the decimal. Use the standard algorithm. Then recognize that it used to have a decimal like it did here. So I'm just playing and pretending over here, and I actually have to put the decimal back. If you take it out, you must put it back. Let's say, and this is the area model that we actually don't have to use this in lesson 11, but hopefully your teachers will show you how to do the area model in class, and like I will with my students. And so we'll take a few minutes just practicing again with the area model to label it in unit form and then get these partial products, and then just recognize that, hey, when I have a number in the 10,000s, that's not really what I started with, because if I estimate before I start, I should have an answer around 280. So clearly this is too big, and that's why you should be reasoning about the placement of the decimal. So it's a lot of steps with the new way. And then at the bottom here, I have kind of a reminder of the old way. We were talking about this, and I had challenged my students last year. I said, all right, let me just toss a problem out to you. What if I have a number with hundredths here and I'm multiplying by a number with tenths here? Where would you put the decimal? So we fiddled around, and everybody's like throwing out all these different guesses, and where do we put the decimal? And we solved this all in standard form, but I didn't put the decimal until the very end. And I said, the old strategy is just count how many place value positions there are to the right, and that's going to be your total. And yes, it's that simple. 1 here, 2, 3, 1, 2, 3. Make a match. Okay? That's what my teacher said to me when I was growing up back in the old days. And now I get to say so many more words. It's not confusing at all. Just kidding. Just sarcasm right there. So anyway, multiply this by 100 so that you can move the decimal out, and now it's by the hundredths because this had two places. This one is by tenths. Hundredths times tenths make thousandths. Here's your final answer with thousandths to the right. Okay, so it all works out. The new way is just the reasoning why I can simply say, let's just count them instead. 1, 2, 3, and that's why it works. Also, if you have access to the sprints, like my class, we will probably spend some time doing the sprints. They are very good practice. Let's move on. So in the book, problem set. And let's start with the directions. Always a good, safe place to start. Estimate the product. Solve using the standard algorithm. Woohoo! Not an area model. Yay, less work. Use the thought bubbles to show your thinking. And of course, everybody's thinking is a little bit different, so mine is never really like what they have. Draw an area model on a separate sheet if it helps you. I don't necessarily find it super helpful, but you can definitely do it if it helps you. I know some of my students are using that, and it helps them, so use it. It is a tool for your math tool belt. So first we're going to think about, what do? I've got to multiply with decimals. And you might think, let's just multiply by 100 so I can move the decimal out. But then, of course, they leave it there. So this is really hundredths. Okay, and we're multiplying by ones. So it's really like 1 times 30. If I was going to round it, approximately equal to My final answer should be somewhere around 30, not too far away from that. So watch out for 3-digit or 4-digit answers, because you might get a lot of digits and then you would say, that's totally wrong. So use the standard algorithm. 2 times 8, 16. 2 times 3, 6 plus 1 is 7, and 2 times 1 is 2. So you have 276 as your first partial product, not placing any decimals in here. Just don't do decimals. This one's done. Hold this placed with a ghost 0 because I'm really working with the tens. 3 times 8, or 3 tens, or 30 times 8 is 24. 4 goes down, the 2 goes up. 3 times 3 is 9, plus 2 is 11. Carry the 1. 3 times 1 is 3, plus 1 is 4. Line up your place value positions so carefully. And then we just add 7, 8, 9, 10, 11. And you can put your carried over numbers wherever you want. We were talking about that. Some kids will say, put it down low so you don't forget. 2, 3, 4, and then 4. So I end up with 4,416. What? Well, it's hundredths times ones. And if I multiplied by 100 here, I have to divide by 100 here. I have to take my 4,416 and divide by 100. That's what I'm doing. And that will then give me the answer that I need. Then you compare. Yes, I do have an answer that is sort of close to 30, even though it's a little bit bigger, but at least the place value positions are not wildly far apart. And so this is just another place for you to write your answer. So your standard form, 44 and 1600ths. Okay? Easy peasy. You got this. And I know I'll never live it down that I didn't push that book up a couple of videos ago. So I'm pushing the book up. So here you can see the next problem. Hooray! Okay, 3.55. Kids are going to go all over the place with estimating. I'm just going to round it up to 4. You could round it up. 35 could go to 40. Some kids will say, well, I want to stick with 3. Whatever. Round this to 90, but some kids might round it to 100, and whatever floats your boat, okay? 9 times 4 is 36, and we have a 0 here. Some kids, 4 times 100, we get 400. We're still in the ballpark. It's still pretty close. This is the thought bubble you have to fill in. So you can copy from up above and say think, but I'm not going to. I'm just going to say multiply by 100. So I'm going to take this, and we're going to take that right out of there. It's just the thought bubble. I'm not actually going to erase it or mar my paper in any way. I'm going to leave it there, but I will be thinking about dividing by 100 at the end when I get my standard form answer, okay? So now we have bigger digits to multiply. That's always more fun. 9 times 5 is 45. And then 9 times 5 is 45 plus 4, 49. 9 times 3 is 27, 28, 29, 30, 31. That's our first partial product. That is 9 times 355 hundredths. Hold this place with your little ghost 0. 8 times 5 is 40. This is the 0 from the 4, 40. 8 times 5 is 40 plus 4 is 44. Carry the 4. I'm just going to use that. It's already there. 8 times 3 is 24. 25, 26, 27, 28. Add those up. Get your 5, 9, 5, 9, 10, 11, and 3. Now again, don't forget, the weird part about kind of using this new strategy of multiply by 100, divide by 100, or renaming it in unit form is like you have to just remember to put the decimal in. Lots of kids will forget to put the decimal in. Half the battle is getting the problem right. The other half of getting this problem right is putting the decimal in, because 31,595 is really not anywhere close to 315. So there you go. So make sure you're super careful. Turn page. On the back, you have a few more opportunities to practice without your thought bubbles. So just round simply and quickly so that you can kind of have your answer in the ballpark. 5 times 8 equals 40. I should be somewhere in the neighborhood of 40. Take your 5.04, or let's say you just want to put 504. You can do that. Times 8. Okay, now I have 32, but we have a 0 here, so I could put the 3 up. It's going to fall right down. Okay, 8 times 4 is 32, 3 is up, here's the 2, 8 times 0 is 0 plus 3, it fell down. 8 times 5 is 40. So I have 4032, and it's a super simple answer. Maybe they wanted to do that to be nice because you're on your own. And we have 1, 2 places here, therefore I should have 1, 2 places here. That's the old way, pretty simple. This is the new way. This is hundredths, THS, I'm always in a hurry. You can set this up as multiplication, and remember that you need to have your answer in standard form there. Same digits, just showing you the new way. All right, this one you can change in a variety of ways. I always have kids arguing, no, my estimate's better, but let's just round it to 150. And we'll round this one to 70. Could you go to 140? Yes. Could you go to 148? I don't know why you'd want to, but yes, you could. So 150 is nice and round. And if you take your 15, I don't really know my 15 times tables. You could also make it easier and just go 100 times 70 and then say that's 7,000. So let's just move on. I can't figure that out in my head right now. See, that's why you want to estimate with something easy. 147.83 times 67. 7 times 3 is 21. And then 7 times 8 is 56. Plus 2, 58. 7 times 7, 49. 50, 54. And 7 times 4 is 28. 29, 30. Then 3 more, 33. 7, 8, 9, 10. Make sure your partial product, 103481. Done. Hold that spot. This is the standard algorithm. 6 times 3, 18. Carry the 1. 6 times 8 is 48, plus 1 is 49. I have to cover all these up. 6 times 7 is 42, 43, 44, 45, 46. 6 times 4 is 24, plus 4 is 28. 6 times 1 is 6, plus 2 is 8. So sometimes kids will say, you go too fast, and you just need to be super careful about how you regroup up here and where you put your numbers. You don't have to do it the way I do. I'm just used to doing it this way, and I don't like to have erase, but some kids like it really, really neat. So it's really up to you, but just don't forget to add those in. Add these up. 10, 14, 6, 9, 10, 8, 9. 8 plus 1 is 9. And then we have, don't forget, we have to put the decimal in. The whole point of today is to put the decimal in. If it's hundredths here, it's hundredths here. When it's hundredths times ones. 1, 2 places here, 1, 2 places there. So the whole strategy is change it to unit form and call it unit form. Then put it in standard form by putting the decimal in. Okay, I'm just doing the standard form right here, which is basically where everybody's going with it. And then eventually you shouldn't have to write those words in because the decimal takes the place of the words. Don't put the decimal and the word because that's redundant. That's like doing it twice. It's like saying 9,904 and 61 hundredths, hundredths. But that would not be correct. So it's just either the decimal or the word, and then you're fine. So, as usual, I'm just going to plop down the answer key so that we can talk through these and kind of keep it a little bit faster for you guys to get in and out. Okay, round to 80. Oh, and by the way, here's the other math, 15 times 7, 10,500. I just don't do that in my head so well. 83 rounds to 80 times 504 times 500. So you want to have, oops, I didn't even have the answer there. 8 times 5 is 40. And then we have 1, 2, 3 zeros. So your answer should be somewhere around 40,000. And when I see my final answer, it is 42,000. So line it up carefully. Take the decimal out. Call it hundredths. Hundredths times ones is hundredths. Here is your final answer in standard form after you go through the whole process. Oh, and I should because we have a 0. 4 times 1 is 4. 4 times 4 is 16. Carry the 1. That's 12. Plus 1 is 13. 3 down, 1 up. 4 times 8 is 32. Plus 1 is 33. 3, 3, 3, 6, 4. This is the ghost for the 4. This is the 0 that holds the place for the tens. And now we're on the hundreds. And you just keep doing that. This is in the second row. You don't need a whole row of zeros. It's just going to add up to 0. 5 times 1 is 5. 5 times 4 is 20. Here's the 0. Carry the 2. 15 plus 2 is 17. Carry the 1. 5 times 8 is 40. Plus 1 is 41. Add, 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 add. There's your label. Here's the standard form. Label, standard form. Now, here we have a number that doesn't even have a whole unit. It's just the approximately half of a number. So what do? Well, on this one, you're going to be thinking about less than. What this essentially means is half. It's half of that. So my final answer is going to be somewhere around 200. Half of 400 is approximately 200. Lo and behold, yes it is. So let's set this up, and eventually you won't have to do the estimating step either. So 432 ones. Oh man, the lights again come on. Give me a break. I just have to move around a little bit more. It's always so exciting on our videos. Okay, so take this out. This is ones, and then call this the unit. This is the new way. Call this the unit. Take out the decimal. Don't bother with the 0. 2 times 6, 12. Carry the 1. 6 times 3 is 18 plus 1 is 19. Carry the 1. 6 times 4 is 24 plus 1 is 25. 2592. 0 to hold the ones place. Move on. 5 times 2. That's the tens. 5 times 2. 10. Carry the 1. 5 times 3 is 15 plus 1 is 16. Carry the 1. 5 times 4 is 20 plus 1, 21. This is not a decimal. That's a carried 1. 2 plus 0, 2. 9 plus 0, 9. 6 plus 5 is 11. Carry the 1 over. 2, 3, 4. That's what that is. Don't let it confuse you. That's probably why people started putting them up on top in the first place. But anyway, that's 4. And then 2. Now this is the label. Hundredths times ones is hundredths. This is standard form because I need to take all these digits and put the decimal where it belongs to turn this number into hundredths. Okay? At the bottom, there's kind of a little bit of reasoning that you have to do, and I always try to make it super quick. So use the whole number product and place value reasoning to place the decimal point in the second product. Explain how you know. So if this whole number problem gives you all these digits, this answer 75,264 in that order, then the same factor here times the same digits here, but not the same factor because it's got 2 decimal places to the right, then you should have 2 decimal places to the right of your decimal here. So when multiplying ones by hundredths, the answer should be hundredths. So they're all like this. 73 and then 1563, 1563 or 1563. These are the digits in this order, but where do you place the decimal? Well, if these are ones times ones, you get ones. If this is ones times hundredths, you get hundredths. If this is ones times ones, you get ones. 46 is the same. 1,239 is the same as 1239 digits-wise, but this one has tenths, and like wabam, they just throw that in there so that it's slightly different to keep you on your toes. So they're not trying to trick you with these answers. It's just the reasoning, again, part of our objective. Reasoning about the placement of the decimal, as you can see at the very bottom. Reasoning. Think reasonably. And at the top of the next page, we have Jenny buying pens, 22 pens that cost $1.15 each, and 15 markers that cost $2.05 each. So these are the markers, and this is for the pens. So if you label everything, the pens and the markers, do your standard multiplication, standard algorithm. This has 2 places here, as you can see. I just didn't even bother to put hundredths and then rewrite it, because by now I know that it's 2 places here, 2 places here. 2 places here, 2 places here. Standard algorithm in between. Add your 2 answers to find the total that she spent in all. And I'm sorry if I'm going too fast. You can certainly pause the video at any time and keep taking your notes until you're all done. And on number 5, here's this nice living room question. They always find ways to throw in the finding area. Area equals length times width. So living room measures 24 by 15 LR, and an adjacent square dining room, please know that adjacent means snugged right up next to it, dining room, measures 13 feet on each side, 13 by 13, and it's okay if they don't look exactly right. This isn't art class, it's math class. If carpet costs $6.98 per square foot, what is the total cost of putting carpet in both rooms? So first of all, find your area for each room, which is using the standard algorithm. Notice that I don't even have anything here because sometimes I just borrow. It's a ghost. Sometimes I just use what I used to do, which is not put anything there. So I'm just going to leave it like that so you can get used to seeing it both ways. Bring down the 0. 4 plus 2 is 6. 2 plus 1 is 3. So 360 feet squared for the living room. And then 13 times 13 would get you 169 feet squared. Again, just multiply using the standard algorithm. These are whole numbers. And then add those together to get the total number of square feet, 360 plus 169. And this is where you finally get to use your new strategy. It's a multi-step problem, clearly very complex. And you take your total number of feet times the cost per foot. And that's where you can take out the hundredths here and make sure you put the hundredths back. Or multiply by 100, divide by 100. It's however you are comfortable thinking about it. And I always just go right back to the, 2 places here, 2 places here. It's not complicated or mathematical, but now that you understand the reasoning behind it, you can do whatever it takes to get these problems right and to place the decimal appropriately. So hopefully this all helped, and I hope to see you soon. Oh, and my students are so excited about all the subscribers. Tell all your friends and hit subscribe. That is so funny. See you soon.